July 2025. Across observatories from Hawaii to Chile, a single line of code in an automated telescope feed triggered an alert that silenced entire control rooms. Astronomers had found something racing into our solar system, fast, steady, and utterly alien in its motion. It was cataloged as 3I Atlas, the third interstellar object ever detected. But even in those first hours, it was clear this one was different at first glance. 3I Atlas looked like any icy vagabond, a silent traveler from the void between stars. But the moment the James Webb Space Telescope locked on, that illusion shattered. Deep in its infrared sensors, Webb picked up something no natural rock should emit, a steady, pulsing glow radiating from the object's core. The brightness wasn't random or erratic. It beat like a heartbeat. Within a day, every model broke down. 3I Atlas was glowing 3 times brighter than it should have been at its distance. Yet it showed no cometary tail, no flicker of reflected sunlight, no hint of tumbling. Its rotation was precise, clockwork steady, as if guided by machinery, not physics. Then came the first real shock. Teams from the European Southern Observatory and NASA's Deep Space Network reported a thermal pulse, repeating every few hours, synchronized with a burst of radio emissions unlike any natural source ever recorded. No comet, no asteroid, no known process matched the signals. If the data held true, humanity was watching the first evidence of something built, not born, an interstellar object with an internal power source. The discovery deepens August 6, 2025. Inside a darkened analysis lab at the Space Telescope Science Institute, a group of near-spec operators noticed something that didn't belong in their data stream. The first infrared frames of 3I Atlas showed a concentrated core of light, tight, bright, and isolated, surrounded by faint, colored bands of heat. This wasn't scattered dust or reflected sunlight. It was a focused emission, pure and stable. No instrument error, no cosmic ray interference. The readings came in clean. Dr. Lena Marvich, senior instrument scientist for Webb's infrared team, checked the calibration logs twice, then reprocessed the data manually. Every run gave the same result, a white-hot nucleus radiating at energy levels 3 times above what any model predicted for an object its size and distance from the sun. No tail, no decay, just a steady, unwavering beacon in the black. Within minutes, the team chat exploded. Could this be outgassing? Is it a new kind of thermal venting? Or something else? Hubble's archival data from June added fuel to the fire, even beyond Jupiter's orbit, where sunlight is too weak to melt surface ice. 3I Atlas had already been glowing. It was active before any solar heating could begin, and now Webb had confirmed it. The glow came from deep within, not from the surface. An object that defied nature. The Atlas Group Observatory in Chile and Hubble's optical analysis teams launched their own round of checks. Brightness was the first anomaly. By every known standard, 3I Atlas shone at nearly triple the intensity expected. Its light curve, the pattern of brightness over time, remained perfectly flat. No dips, no surges, no signs of rotation-based shadowing or gas jet flickers. For comparison, normal comets are messy. They brighten, fade, and sputter as their icy crusts vent in chaotic bursts. 3I Atlas, by contrast, was eerily consistent. Its rotation period of roughly 6 hours should have exposed hot and cold regions. But the light stayed uniform, like a machine calibrated to hide its seams. When Hubble zoomed in, astronomers expected to see a comet's tail, a streaming plume of vapor trailing behind it. Instead, the object sat inside a tight, teardrop-shaped cocoon, almost symmetrical, more like a shroud than a plume. And even at 6 astronomical units from the sun, far beyond the realm where comets awaken, 3I Atlas was already burning with energy. No model of solar heating could explain it. No equation fit the timing or the luminosity. Something was wrong, and thrillingly so. The pulse data accumulated. Webb's infrared analysts noticed something subtle yet astonishing. Every 4 hours, the object's central heat signature swelled, then faded again. Not randomly, but rhythmically. Each cycle was smooth, deliberate, precise. A mechanical pulse echoing through the void. The logs filled with timestamps marking every rise and fall. Dr. Marvich's team mapped the intervals against 3I Atlas's rotation and orbit. Nothing matched. The pulse didn't track sunlight. It didn't depend on its angle to the sun. It came from deep within, radiating outward in thermal waves as if something inside were alive, or running. By the end of that week, one question consumed every private message thread in the astronomy community. What if this isn't a comet at all? To the James Webb operators, the pulse no longer looked like the chaotic venting of gas or heat. It looked like a heartbeat, measured, deliberate, engineered. By mid-August 2025, radio observatories from California to South Africa swung their massive dishes toward 3I Atlas, tuning into frequencies rarely explored for natural cosmic objects. If something artificial lay beneath that glow, it might speak not in light, but in radio. At the Allen Telescope Array, Dr. Kavita Ralph led a restless night crew through terabytes of wideband data. They filtered out the usual suspects: satellite noise, cosmic hiss, even the whisper of the galactic background. Then, buried in the static, they found it, a faint, narrowband pulse, repeating every 4 hours, unwavering in frequency and tone. Fourier analysis confirmed it. Not random, not drifting, but a stable carrier wave, razor-sharp against the background static. Over several nights, the pulse remained constant, yet its timing drifted slightly, not randomly, but in sync with subtle solar wind fluctuations, as if 3I Atlas was somehow aware of its environment. Independent teams at Meerkat in South Africa and Effelsberg in Germany confirmed the same signal. It wasn't local interference. It wasn't terrestrial. It was real, and it was coming from deep space. The question none of them wanted to ask now became unavoidable. Is this a natural resonance? Or a transmission? The flare mid-August 2025. Without warning, every telescope on Earth and in orbit caught a sudden surge. 3I Atlas brightened by nearly 40% in under an hour. A violent flare across the visible and thermal spectra from Earth's orbit. The test satellite confirmed it. Infrared readings spiked, radiation levels climbed, and the object's heat output briefly reached that of a small fusion reactor. Then, just as quickly, it faded, but not to normal. Its new baseline brightness was permanently higher. As if whatever powered it had switched to a higher state, attention immediately turned to its orbit. At the European Space Agency's Near-Earth Object Division, orbital modeler Marco Michelli compared new trajectory data with predictions. Something was wrong. The path no longer matched. 3-1. Atlas had shifted its course, bending inward toward the plane of the solar system, a maneuver no comet or asteroid should be capable of. The usual explanations: outgassing jets, gravitational drift, measurement error, all failed. The change was too controlled, too smooth, coinciding perfectly with the moment of the flare. It was as if the object had decided to adjust its flight path. The impossible spectrum, August 18, 2025. With the Webb's near-spec instrument pushed to its limits, the investigation passed to Dr. Kerry Liss's spectroscopic team at Johns Hopkins University. Their job: identify what 3I Atlas was made of. At first, the spectra looked ordinary: water, carbon dioxide, a trace of ammonia, all the ingredients of a typical comet. But buried among those familiar signatures were absorption lines that defied every catalog. Some hinted at metallic alloys unknown in nature. Others reflected the telltale patterns of rare earth elements, the same used in advanced terrestrial manufacturing. Then came the strangest find: a handful of narrow spectral features aligned with theoretical quantum materials, exotic compounds that had only ever existed in mathematical models, never observed in the real world. For the first time, the whispers around the labs took form. This wasn't formed. It was forged. The implications were staggering. If confirmed, 3I Atlas wasn't a rock from another star system. It was a machine built somewhere out there, locked down by late August. Something shifted behind the scenes. Access to telescope data suddenly tightened. NASA, the ESA, and the IAU circulated internal memos, referencing planetary security and information control. Webb's live data stream was rerouted through encrypted servers. The newly formed Solar Encounter Initiative, say, a joint task force of astronomers, linguists, and communication theorists, debated a single, terrifying proposal. Should humanity reply? After 3/10 votes and international consultations, they agreed. A mathematical transmission was sent toward 3I Atlas, a signal made of prime numbers, elemental constants, and the periodic table of Earth's chemistry. It was simple, structured, unmistakably intelligent. For 72 hours, the deep space monitors waited. Then, after 19 UTC, a reply arrived, a faint, narrow-band echo, matching the transmission window to the second. Distorted but deliberate. It was not a reflection. It carried modulation, structure, intent. Within minutes, the data was seized by agency officials. External communications were shut down. What had started as an open collaboration between scientists became classified overnight. Outside the labs, rumors exploded. Inside, the mood shifted from excitement to something closer to fear. The countdown at the August IAU debate. Every natural model was tested, outgassing, radiogenic heating, dust scattering, mass estimation errors, and all failed. None could reproduce the rhythmic pulse, the spectral anomalies, the radio reply, or the sudden orbital change. By late September 2025, the world stood on edge. 3I, Atlas was on final approach, its closest pass to Earth only weeks away. Every major observatory, from Webb to ALMA to the Chinese fast array, prepared for the flyby. No one knew what would happen next. Would it pass harmlessly into the dark, or would it do something no object had ever done before? One fact remained clear, and it haunted everyone who had seen the data. 3I, Atlas does not behave like something born. It behaves like something returning home.